Hi, we're doing a parametric equation, and this is an advanced late-stage Calc 2 problem. So if you're in pre-calculus or calculus looking at this video as an example of how I teach, just know I'm going 5 times faster than usual because I have to get this in under 5 minutes. This is our parametric equation. X equals 4 cosine squared 2t, y equals cotangent squared 3t plus 1. Our points of interest are 0, 2, 3, 2, and 1, 1. Which corresponds to the t values, or time values, pi over 4, pi over 12, and pi over 6. We're trying to find the area under the curve from 0, 2 to 3, 2, and the length of the curve from 0, 2 to 1, 1. So we're trying to find the area under this curve and the length of this curve. Noting that as t increases from pi over 12 to pi over 4, we're moving from right to left instead of left to right. This is important when it comes to the limits of integration that we will see later. Okay, now in this step, when finding the t values, right, this is all pre-calculus, right? We plug in 0 for x, right, to get 4 cosine squared, 2t equals 0. We do a bunch of pre-calc. We get 2t equals pi over 4, t equals pi over 2, implying t equals pi over 4. We plug in pi over 4 back into cotangent squared 3t plus 1 to get 2. Convince yourself that these steps matter. These next two, I've skipped even more steps to give you more practice in case you need practice with pre-calculus and the unit circle. Again, the points are pi over 4, pi over 12, and pi over 6 respectively. All right, when setting up the area of an integral from a to b of any graph f of x, right, or y dx, we have these values, we know what y is, and we're given x, right? We need to figure out what dx is. So dx dt equals 8 cosine 2t times the derivative of cosine 2t, which is minus sine 2t, times the derivative of 2t, which is equal to 2. That's a chain rule within a chain rule situation, okay? Giving us minus 8 sine 4t. dy dt is 2 cotangent 3t plus the derivative of cotangent 3t, which is minus cosecant squared 3t times the derivative of 3t is 3. Another chain rule within a chain rule, giving us minus 6 cotangent 3t cosecant squared 3t. Okay, giving us dx dt equals minus 8 sine 4t, or dx equals minus 8 sine 4t dt. dy dt equals minus 6 cotangent 3t cosecant 3t, which we will use in length. But right now we're looking at area. Area from a to b, y dx is a to b cotangent squared 3t minus 8 sine 4t dt, where a is 0, 2, and b is 3, 2. Noting that t2 corresponds to a and t1 corresponds to b, okay? Now, cotangent squared plus 3t plus 1, you should know from pre-calculus, equals cosecant squared 3t, so we get this as our final integral from a to b, pi over 4 to pi over 12. Noting that when you switch the limits of integration, that gets rid of the negative sign. This is our simplified integral that the problem is asking for, giving us an area of 3.6697. Now when we're looking at arc length, we use the formula length equals limits of integrations t1 to t2. Again, t1 here, right, for the arc length is going to be pi over 6. t2 is going to be pi over 4. So from t1, pi over 6 to pi over 4, the square root of dx dt, which is 8 sine 4t minus 8 sine 4t, and dy dt is going to be minus 6 cotangent 3t cosecant 3t, right? We plug those in, then minus 8 sine 4t squared plus minus 6 cotangent 3t cosecant squared 3t squared, giving us 64 sine squared 4t plus 36 cotangent squared 3t cosecant 4 3t. We can pull out a 4, making it a 2 on the outside of the radical 16 sine squared 4t plus 9 cotangent squared 3t cosecant to the 4th 3t. Okay, again, from point 1, which is pi over 6, to point 2, which is pi over 4. Plugging this in to the calculator because the problem does not ask us to evaluate the integral step by step. It says just set up the integral. This is the simplified integral using this formula for arc length for parametric equations, and that gives us 1.66906. So the arc length is 1.66906 from here to here, and the area under the curve is 3.6697. Now keep in mind, this is advanced math. It would take me normally 15 minutes, 20 minutes to teach this to a student, but I only have 5 minutes. If you're in a class that's not Calc 2 and not an advanced Calc 2, don't be intimidated. These are just the tools that I use. This is just a display of what I do, only on hyperspeed. If you have any questions, feel free to contact me on Wisent. Thank you.